We don't compromise our beliefs in power quality. By that I mean every product that we manufacture has isolation in it. Because you can't see power quality, I can talk till I'm blue in my face, anyone can, because it becomes a specsman game, ship game at that time. We really don't play specs with our customers. We show them real time what products do, and we show them real time what POWERVAR products do.
And that's where the scope and probe demo comes in, where the customer can see the performance difference between a POWERVAR product and the competition. So we rely on these tools where you can actually look at power to see what's actually coming out of these so-called power quality devices, and then compare it to POWERVAR, real world, real time, and then they can make up their own mind.
When we show the customer what power quality is doing to their overall performance and we eliminate that, they're a long-time customer. We don't lose customers because of our competition coming in and taking it from us. So without the scope demo, we're no different than anyone else in the industry. One of the most common questions that I'm asked by customers is, why POWERVAR? What makes POWERVAR different? Well, today I thought I'd take some time to show you exactly why POWERVAR is different. What is the difference between our products and the rest of the industry? If you take a look at the marketplace, we have about 600 manufacturers all touting that their products eliminate power as a variable for disruption of electronic systems. Well, what you're going to see here today is that not all products are created equal. And the industry plays on the fact you can't see what their products do with the energy that's generated from loads running on the power line. What I have with me today are a couple devices to help me look at the power in this building here. What you're going to see is that noise really does affect the operation of systems, and it affects it based on the performance of how the systems handle the interface of the power to the electronic systems. What I have are a couple devices here. I have an oscilloscope that allows me to look at electrical signals, and I have a device here that's manufactured by POWERVAR that allows us to look behind the scene. Number one, what you're looking at the scope right now is an AC sine wave, that generated by the utility. But this probe has two other features to it. It allows you to look behind the scenes at the AC power in respect to two areas. The first being the noise between hot to neutral or phase to phase, which I'll be referring to throughout the course of my demo here in terms of what are destructive levels of noise from that area. The second probe on here allows me to look at the noise neutral to ground. Now, there are a couple studies out there in the industry that really dictate what are performance characteristics of devices, how they interact in the field, and what are levels that really cause disruption, degradation, or destruction of those components. The first is a study that's done by the IEEE, and the IEEE has looked at what is the worst case waveform that you can see on the electrical distribution system. What they have determined is that the energy that's generated from a lightning strike can create up to 6,000 volts of noise on the power line that can be very destructive to devices that are plugged into it. So in looking at worst case waveforms, that being a lightning strike in the area, what are acceptable levels for today's electronics? If you talk to the semiconductor manufacturers, what they will tell you is that acceptable levels of noise between hot and neutral are 10 volts or less. With noise respect to ground or common mode, you never want to see more than a half a volt with respect to ground. Reason being is that microprocessor references ground in making its logic decision, so if that transient or spike coincides with the clock pulse, the system locks up, does something stupid, maybe sends an order to the wrong terminal. But at the end of the day, if you can keep those levels to less than 10, less than a half, you really can attain system reliability. And that's really what POWERVAR is about. All of our products are designed to eliminate those factors from getting in and causing degradation, disruption, or destruction to the system. I want to start today by looking at some of these products that are manufactured in this environment of 600 manufacturers. The simplest has to do with a surge diverter. And we call it a surge diverter for a simple reason. Number one, It doesn't suppress anything as its name. The industry calls it a surge suppressor, but it really diverts energy to protect the equipment from unwanted energy. Now, the real problem with this device is, and what most manufacturers don't tell you, is that the device doesn't turn on until levels exceed 330 volts. So in order to look at this, I want to give you a little overview here of what I'm looking at on my oscilloscope. Earlier I mentioned the fact that our power probe has 3 functions. The first allows me to look at the waveform that you can see here on my oscilloscope. I like to start with that for 2 reasons. Number 1, I'm looking for any type of distortion to that waveform. That will help tell me whether circuits are overloaded or transformers are overloaded. The second reason I like to show it is I want you to see how clean it looks. Now, my scope in conjunction with the power probe are only allowing me to look at the 60 Hertz properties of that waveform, so we see a nice clean waveform. What you can't see is the high frequency noise that's riding on that waveform.